This week, we are going to discuss waste management as it relates to sustainability, in particular, with a special focus on greenhouse gas emissions and sustainable energy as it relates to the topic of waste. So, here we go with our lecture of the day, waste management. Now, this is a very broad subject, and it could cover many different elements and areas, and you may have a particular favorite topic or interest. And I will here today just give a brief overview and outline. There are some things we will not discuss when we discuss waste management, and we'll bring forward a few key issues, general concepts to be aware of, and kind of how it all works when it comes to waste from a modern perspective. So when we discuss waste management, we are talking about some very specific things. First of all, the waste is human produced. So there are other naturally occurring things that may be harmful, toxic, or otherwise problematic. We're not worried about that from a waste management perspective. For us, we define waste as something produced by humans, which is kind of an interesting concept when you think about it. Waste in nature simply doesn't exist. If there's an extra amount of something, something else usually comes along to eat it. And so waste is kind of a human invention, something unique to human activity. And one way we could try to solve waste and the issues that surround them is to just try to find something else that, quote unquote, eats this waste product. And maybe it's another industry using it as a resource, or maybe it's some kind of natural process that we could introduce this material to. And it has been said that waste is simply an unused resource. And if we're clever enough, we can come up with a way for it to be used, and then it won't be considered waste. And if we don't use the resources, they tend to accumulate to the point of pollution, and then they become problematic. So waste is simply an unused resource, and we need to prevent it from accumulating so that it does not cause pollution. Kind of an interesting way to think about things. Now, in our modern world, when we talk about waste management, we are discussing something very specific. Usually, we're referring to municipal solid waste, which is the bulk waste that's created by households, industry, or commercial activity. It does not include hazardous waste, which is certain toxic chemicals created as byproducts of industrial processes, nor does it include construction waste, and it often doesn't include things like land contamination. So when we talk about waste management, we're looking to reduce the adverse effects of waste on health and the environment, and primarily we focus on municipal solid waste because it's one of the most urgent issues. It's also one of the more easy to affect and manage. And here's an image that tries to illustrate the effect of poor waste management. We can see basically trash as far as the eye can see in an open landfill type of a system. We see people living and working around the landfill, either scavenging for those resources or otherwise living in a condition that's harmful to their personal health. We can see the wildlife, the birds coming in to eat the waste, causing all sorts of potential problems to the wildlife. And then we can see the fumes, the gas rising from the landfill. And this is presumably steam. Maybe there's some decomposition of organic matter. Or it could be even a small fire that has been lit in order to help reduce the volume of the waste. So from many perspectives, there's a problem here. And this is causing lots of potential issues. So proper waste management is a way to try to reduce the impact of the accumulation of waste. When we consider waste, we try to categorize it to better understand. And we can see that waste is on the rise, basically. More people, more waste. And the consumption patterns of those people can either be more or less wasteful. Basically, unless urgent action is taken, we can see that the waste generation is on the rise. And we have massive increases of waste produced globally. And you can see a breakdown by different regions of the globe, who produces the most waste annually, and then a breakdown by category of waste: metal, glass, plastic, paper, and green or food waste as the main types of waste generated. Now, all of those things, you may notice, are recyclable in one form or another. So naturally, we quickly jump to recycling as a solution. When we look at waste management, we tend to break it up into 4 key elements of managing the waste. We can sort of diagram every step in the process. The 4 main steps are the collection of waste, the transport of waste, any treatment of the waste, and finally disposal. At each step in the process, there's opportunity to streamline, to enhance, make it more effective. And we need people to solve problems at all 4 steps in the process. This brings us to recycling, as I mentioned. But are there better alternatives than recycling? Well, yes, there are. And we can put those alternatives in order of their priority. And that creates what we call a waste hierarchy. So the aim of the waste hierarchy is to extract the maximum practical benefits from products and to generate the minimum amount of end waste. And you may have heard some marketing campaigns from long ago that would have the 3 R's, the simple phrase of recycle, reduce, reuse. Well, it turns out that if we follow that order, recycle, reduce, reuse, that's not following the proper waste hierarchy. Recycling is actually less preferable than reducing or reusing. If we reduce in the first place, then we limit the waste generated at all. And then if we can reuse the product as is without needing to transform it into something else, then that is more effective from an energy standpoint. And then if we cannot reuse it or reduce it, we recycle it. Recycling means we turn it into something else with the input of energy. And so you can see the diagram here, the little graphic showing that first we want to work on source reduction and reuse. This would include recycling and composting, things like that. Next, from a municipal waste perspective, there's biorefinery, which involves capturing liquid fuels or chemicals out of the waste material. After that, there's a waste-to-energy process, which uses heat and electricity, but we can basically burn the trash and use that to create electricity in a power plant. And then finally, the least preferable in the waste hierarchy is landfill. Now, there are other steps in this process. Take food waste, for example. We could look at a subcategory and find other alternatives. Reducing the food waste generated is, of course, number 1. Secondly, we could feed hungry people with the extra food. We could feed hungry animals with the extra food. Finally, we could compost that food and turn it into a soil. And then if we couldn't compost it, we would look at trying to divert it in another way. So there are sort of subcategories for certain waste stream elements. But this is a general concept of the waste hierarchy. If we want to look at this in greater detail, we can see some more possible things. And admittedly, this is kind of a chaotic looking graph, but it just shows that there are many ways to think about the ways that we can divert material from the landfill. And we have a range of options oftentimes. And the most favored options would be up at the top of the diagram, where we reduce, meaning we focus on prevention or minimizing, choosing alternatives that have a smaller impact. And we're looking at certain scope of who's responsible. And then we can work our way down toward the least favorable. And these are things like recycling, incinerating, and finally disposing in the landfill. So there's issues with each of these. And ultimately, the more we can reduce and reuse, the better off we are. This brings us to a concept of life cycle analysis, or the life cycle of a product. And if we analyze a product's life cycle, well, this is a way that we can optimize the use of limited resources and avoid unnecessary generation of waste. So the life cycle analysis of any kind of a product involves a few areas where we try to plan ahead on how this product can be used and perhaps reused before it is made and sent out into the world. So is there a way that we could design products to be better reduced, reused, and recycled? In the manufacture of products, is there a way that can encourage them to have a longer life? One example of manufacture is when we combine materials. If we laminate paper with plastic, now it is neither recyclable from a plastic nor a paper standpoint. So can we manufacture products with the intent that they can be repaired, deconstructed, and that their material parts could be reused or recycled? Distribution, primary use, the product's reduction, reuse, and recycling can all be considered in how we build products in our world. And this way of looking at manufacturing and consumption is called life cycle analysis. And it is a big opportunity in our world today. Many industries find that they are purchasing inputs, resources to build their product or provide their service. And if they just looked a little bit more carefully and creatively, they could link with other industries so that the waste product of one could become the resource of another. And if you connect enough industries together, maybe we can get to something called a circular economy. Now, one benefit of looking at the life cycle analysis is that we can have greater resource efficiency. And basically, this means we can reduce the environmental impact from the production and consumption to the final material extraction, the last use, and disposal. So this diagram is showing the circular process of product manufacture, packaging, distribution, product use, recycling, composting, disassembling, and hopefully trying to make that a circle. And then notice the green box in the middle is indicating that every step of that process requires labor, energy, and materials. And there is waste at the product manufacture and the product use end of the system. There's probably waste at all of them too. Packaging, distribution, maybe there's different forms of waste. And we have an opportunity for reuse while the product is in use and being consumed. So yes, we want to make this a circle, but every time it advances down the line in the manufacture, distribution, that involves energy. So the more we can make the resource use efficient, the lower we can have the environmental impact. Some people say, yes, this is great, but in a capitalist economy, there's no incentive. Why would the companies choose to pay to do the right thing when that is not going to make anybody any money? Well, there are a few proposed solutions. One of the solutions is what's called the Polluter-Pays Principle. Basically, this is an idea where policy can be enacted so that whoever creates the product that is turning into waste is required to pay for the impact on the environment. So if you have a big negative impact on the environment from something you made, well, now it's your job to pay the price for that. And when you pay the price, you will be now incentivized to reduce your environmental impact. This could include all sorts of things, everything from the pharmaceutical industry, people who produce medicines. When those medicines are, maybe flushed down the toilet, they enter the environment and cause all sorts of problems. Well, the polluter pays principle basically requires that the pharmaceutical industry take back their medicines and recycle them appropriately, otherwise pay for the environmental damage done. And you can imagine similar things for all sorts of industries, including styrofoam, plastic, all sorts of things, mattresses, construction, and a growing movement among small city governments and state governments is to encourage the polluter pays principle, basically saying it's not the consumer's job to find a way to recycle this material. It is the producer's job to produce products that are able to be recycled better. And then this brings us to the idea of waste handling and transport. And basically, we have curbside collection, which is the most common method of disposal in the developed world. You put a little bin out by your curb and someone comes and picks it up. The state of California has really adopted mandatory recycling and composting as part of curbside collection. This legislation started basically in the city of San Francisco, who created a zero waste by 2020 plan. And that required diversion from the landfill at a rate that was higher than any other place, meaning all of the food scraps generated by homes and industry would need to go toward a green waste recycling, sort of a composting program, in addition to the paper, the plastic, the glass, the metal that gets recycled in the blue bins that are picked up curbside. Now, this legislation went on to influence state legislation, where now we have statewide rules that limit the amount of organics that can go into the landfill. And all across the state, local governments are required to divert their waste, meaning that anything that's going to produce greenhouse gases should stay out of the landfill. And how do you do that? Well, mainly by composting on a large scale. But before we even look closer at how the developed countries work, this waste handling and transport piece is very important to consider. It's one of the #1 things we can do in the developing world, is to just pay for municipal waste collection. A lot of the pollution ends up in the local waterways, on the beaches, in the oceans, even in the surrounding environment, simply because there's no centralized system for dealing with waste. And although dumping everything in the landfill is not the perfect thing to do, it is one of the easiest things to do to really improve human and environmental health at a local level. So if we're going to be advocating for waste management on a global scale, one of the first things we need is just to have trash trucks out there picking up the trash and taking it to a landfill. That can do a lot to improve the pollution problems all over the world. Now, in the developed countries who already have proper waste collection systems, now we need to focus on diverting the material from the landfill so that that landfill is the last and final option. We've tried to do many other things. And here in California, we're currently focused on green waste, organics collection. So here's your typical image of a landfill showing kind of the disposal methods. Here we can see this is very coastal, probably in a tropical region. And notice we're trying to keep the trash, in this case, out of that ocean environment. The landfill is lined with plastic liners so that any liquid in the trash doesn't go down into the groundwater and potentially out to the ocean, causing pollution. So here we see a relatively clean and relatively organized landfill system. On islands and in urban areas where there's not much space, landfills become a very important but very controversial topic. Nobody wants a landfill in their backyard, at least while it's being filled up. Once it is capped off and restored, in theory, you won't be able to notice that much landfill has been there at all. But while it's going on, nobody wants to live next to a landfill. And these are non-renewable systems. Once it's full, you need to start putting the trash somewhere else. So diversion is really important. There are some local point source pollution possibilities coming from these landfills as well. And one of these is in the form of that leachate, the liquid that drains from the trash. So here we see an image of a detention basin. This is a lined basin that is designed to catch all of the liquid that drains out of the landfill, including rainwater that washes through the landfill. We don't want that rainwater, which gets contaminated with trash and debris, to flow into the natural waterways. So it goes into a collection system where it can be treated before it's released into the environment. Now, as I mentioned before, food waste is one of the major opportunities for reduction in the landfills. It's the #1 source of garbage in most landfills and is responsible for a large percentage of US methane emissions. Now, methane is a greenhouse gas which contributes to climate change and global warming. It's actually a very strong greenhouse gas. The methane molecule traps heat much more effectively than the CO2 molecule. So for every methane that's released, it's about 25 times more powerful than CO2 at trapping in the heat. So reducing methane is a very big priority from a greenhouse gas emissions reduction perspective. And here we can see a graph showing a breakdown of the food losses and food waste by continent and who is responsible, the consumer or the producer. So we can see in Europe, North America, and industrialized Asia, there is a large amount of food waste produced, first of all, and a big amount of that is produced by the consumer. A lot of people purchase the food and then they let it go to waste. If we look at sub-Saharan Africa, North Africa, Southeast Asia, and Latin America, the consumer created food waste is much less, and the overall amount of waste is much less. So in the landfill, when you add organics, those organics break down. With the lack of oxygen caused by the burial of this material, you get anaerobic decomposition. One of the byproducts of anaerobic decomposition is landfill gas. The landfill gas contains methane, which is a very harmful greenhouse gas. And what do landfills do? Well, they put wells, gas extraction wells, down into the landfill with a series of pipes that they can pull air through in order to capture the greenhouse gases. Sometimes those greenhouse gases could be turned into fuel. So you can harvest that and either liquefy it or turn it into a combustible fuel. You could run machinery and vehicles off of harvested greenhouse gases from landfills. And what you cannot harvest and turn into fuel, at least it is burned as kind of a flaring system. So at night, if you check out a landfill, you'll oftentimes see a flame that is lit and glowing 24/7. What are they doing? They are burning the methane. When you burn methane, or when you burn anything, you release CO2, carbon dioxide, but converting the methane into CO2 is at least better than releasing the methane directly. So ideally, we don't generate the methane in the landfill. If there's going to be some methane generated, we can try to capture it and use it as fuel. And if we cannot use it as fuel, last but not least, we want to try to flare it off so that it can at least not go into the atmosphere as methane, but instead enter the atmosphere as CO2. You can see the diagram shows a very intricate and organized system of building a landfill. So it's compartmentalized into waste cells, and there's a liner system capturing any leachate, and it's built in a way that we can harvest the gas that will inevitably be generated from the landfill. So there's a very sophisticated engineering system going on at your modern landfill systems. Now, there are opportunities at every step of the way to harvest this material for energy, either as a fuel, a natural gas, or to create electricity. The most simple system for waste to energy is incineration, meaning we literally just burn the trash. When you burn the trash, there are some benefits. One of the benefits is we reduce the volume of solid waste up to 95%. We get rid of the bulk material. We don't have to put it anywhere. This is common in countries where land is scarce, including on island nations. And this could be incorporated into a waste-to-energy facility where waste is burned in a furnace, and that is used to generate heat, steam, or electricity in order to produce energy that can be used. So that's great. However, we do have the air pollution problem that comes off of waste incineration. So burning the trash is certainly not the best option, but it would be a step up on the hierarchy to have it produce energy than it would be to just put it in a landfill and have the methane go straight up to the atmosphere. Next up, we can take a look at recycling, which is what most people think of when they think of doing the environmentally friendly thing. If we can recycle the material, we keep it out of the landfill, and it has a chance at another life. So recycling is simply the collection and reuse of waste material so that it can be reprocessed into new products. There's a couple different types of recycling schemes out there, and the main two that you have options for are owner-separated or single-stream recycling. Now, it used to be that we had owner-separated recycling where you would have multiple bins and you would have to sort out your paper, your plastic, the metal, and the glass so that each of those could be collected separately and sent to a separate recycling facility. Eventually, people learned that if we allow the owner to just put everything in one group, single stream recycling, well, then it would be easier. We would get more material and more recycling would happen. However, what is required now is at a recycling collection center, we need to separate out the material and turn it into multiple streams that can be sent to their proper recycling location. So locally, when you recycle as an individual or as a business, it is single stream recycling, and all of that material is taken to a single place. Then it is separated and sent out to further recycling. Many things can be recycled. Not everything is recycled, but of the things that can be recycled, we think of aluminum cans, copper, wire, steel from the food cans, rubber tires, plastic bottles, glass bottles, paper, cardboard, etc. Other things such as styrofoam and many other products are recyclable. However, they rarely get recycled because it's very expensive to recycle that material, and very cheap to create that material from scratch. So the economics really play a big part in this process. The economics play such a big part in the recycling process that typically the way it has historically worked in California is all the material is collected locally, and then it's not really recycled locally. The reason is there's not a lot of manufacturing here locally where the recycled products would even be useful. So where does the recycled product go? Typically, it would go overseas to China primarily, where most products are manufactured. They're the ones who would want to receive the raw material input for recycling. So for many years, a system has been in place where when you recycle in California, that material is separated and sorted and then sent on the ships that go over to China. They bring goods from China. They go back with recycled trash, basically, to be turned back into new products. And that system worked okay for a while, until relatively recently, when the Chinese government announced they were going to change the rules for what types of material they accept and what tolerable levels of contamination in the recycled material they collect. So starting in July of 2017, the Chinese government announced an import ban of 24 categories of recyclables and solid waste. And this has placed tremendous impact on developed countries globally, which had created their recycling systems based on exporting either directly or indirectly to China, where those goods were then manufactured into new products. And to this day, we have not really solved the problem. So right now, there's sort of a challenge where we have a system of recycling in place, but that recycled material has nowhere to go because there's no other good place for recycling that much material, at least locally. So local governments are really pushing to develop industry locally that receives recycled material. The more we can distribute that recycled material to turn into products in other places instead of a single place, we can actually get it to happen. But right now, as it stands, a lot of our recycled material has nowhere to go. So where does it end up going? Unfortunately, straight into the landfill, where we want to keep it out of. And so you should still keep recycling, still keep encouraging others to do so, but we need to hurry up and figure out a good place to send all of this material so that we can keep this material from the waste stream, get it back into producing new goods and services, and have a proper, hopefully ever improving waste management system. Although there's also a lesson to be learned here, where we need a diversity of solutions, and we cannot rely on a single solution for an entire system. If we build a system that relies on everything going to a certain place, well, one day that may not be possible for a number of reasons, and now the whole thing stops and breaks down. So no matter what, it's important when it comes to waste, when it comes to all sustainability, to have backup systems or some redundancy in how we build our world. And ideally, we should have a local option. If we're going to work collaboratively internationally, of course, that's a great idea, and economics usually will incentivize that. But there should always be some local backup system in case of emergency, or even just to ease the load of a complex system. It's sort of our backup insurance for when those systems have hiccups or even fall apart completely. And the lesson being learned here today is around recycling, but we'll have similar lessons over and over until we kind of figure out a good system for handling all these things at a proper regional scale. So there we go with our lesson today on waste management. I hope you found this information interesting, insightful, maybe helps you to understand kind of from a big overview perspective a few of the points in the process and ways we can intervene in order to make it more efficient, require less energy, save energy, and reduce pollution all at the same time. Looking at things from the perspective of their life cycle, doing a life cycle analysis, and overall trying to encourage the reduction, then the reuse, next recycling, and working our way up the waste hierarchy so we can avoid things going down the wrong path. Hope you found this topic interesting. I look forward to talking about it more in the coming weeks. Thanks a lot.